So the derivative of tangent is secant squared the inside. Now I have to take the derivative of the inside. And to do that, we're going to use the product rule. So we're going to multiply this product rule. So the derivative of x squared is going to be 2x, then times the second, plus the derivative of the second, over dx if you like that. So I'm going to put, actually I should probably use a bracket right here. So it's this times this whole thing. And because there's a y prime in there, I know I'm going to have to distribute this, which kind of stinks. So then we have equals. Let's do the other side. Hopefully this side's a little cleaner. This side we have, again, we have to use the product rule, so we have 3. And we drop that, and then we subtract 1 away from 3. Then I have to multiply that times the derivative of the inside. So that's going to be, the derivative of x is just 1, plus, and that's going to be y prime. Okay? Now, to finish this problem, you're going to have to get the y prime alone. So you're first going to have to take this and distribute it, multiply this times this, and this times this. And this one you're going to have to distribute also. Yeah, okay, Matt, you're right. This one gets really gnarly really fast. That's why you chose not to do it? Like, I'm done with that one. Yeah, if you don't have that much time, I would press pause on this one and go back to it later. So then I have to distribute this one to the 1 and that to the y prime. And then I have to get the y primes on the same side and then divide, which is going to be a long process. Okay, so here we go. If I go secant times this first term, it's going to be 2xy times secant squared of x squared y. And then multiply it times the second one, it's going to be plus y prime times x squared times secant squared x squared y. And on the other side, we're going to have 3 times x plus y squared times the 1. Then we have to do 3 times xy squared, or x plus y squared times the y prime. So that's going to be plus, we'll put the y prime in front, times 3 times x plus y squared. Okay, so we need this guy and this guy on the same side. So I'm going to subtract this so that he's then with this. And then I'm going to subtract this guy, so now he's going to be with this. No, not that, with this guy. So let's rewrite what we have. I'm going to try to fit it all in one line here. We have y prime, x squared times secant squared x squared y, minus y prime 3 times x plus y squared, equals 3x plus y squared. So that's this guy right here. He's already on the right side. And then I'm going to subtract this from him. So it's going to be 2xy secant squared x plus, x squared y. Wait, that should be minus right there. Alright, so that's all that. Now I would factor out this y prime. So I don't have to write the whole thing again. Actually, let's use brackets. Let's factor out the y prime. So now my y prime, to get that alone, I'm going to have to divide both sides by this. Man, this problem is so gnarly. So we have y prime equals, actually let me get some more space down there, 3 times x plus y squared minus 2x y secant squared times x squared y. Well, not times, in the secant. And then dividing that by x squared
times, actually I don't need those parentheses, times secant, this guy right here, secant squared x squared y, then minus the rest of this, so it's going to be 3 times x plus y squared. Now it would be really nice if I can factor some things out and cancel them, but it doesn't look like I can do that. Keep in mind this right here is just a really nasty looking binomial divided by a binomial. Because of this minus right here, the top is a binomial, and because of this minus right here, the bottom is a binomial. Whew. I'm looking. Yeah, I can't factor anything out from each of these terms or from each of these terms so that I can cancel something out. That problem is really gnarly. That's your answer.